security has become a primary concern as well as wireless or wired networks. We are known. In the presence of jammer, which router is more secure for the data communications in the ad hoc network and for the defense sector is the basic aim. Security is used in intelligent networks. We know the jamming is any attack to deny service to legitimate users by generating noise or fake protocol packets or legitimate packets, but with spurious timings. But there are a lot of jammers are there, but we are considering about the intelligent because they are attacked at a particular time or the particular extent, particular time. Why? Because they are so efficient. Jammer can choose to disturb select control packets for every short time and bring down the whole network. We know the concept regarding if the noise will be there and if the control packet size is less than your DIFS size, then there are some of then there are some effects and the channel is not ideal conditions. There are some busy conditions. Objective of research to demonstrate the comparison of intelligent jamming RF layer with WLAN Ether router and WLAN Ether bridge. Similarly, design goal is the same. Methodology. I was worked last 3 to 4 years on OpNet modeler. Before OpNet modeler 10, now 14.5 we have. And the requirement of solution tool is minimum. We know this is a system requirement. Is a Pentium 4, basically, and the RAM is minimum 512 MB. Computer environment is I was using, or I am right now using Windows environment. Mobility model, we know there are 4 basic models in the OpNet modeler called network model, node model, process model, and link to state. Various models also there. Basically, the main idea on the node model is the resource coding, source coding is there. Now solution result and discussion, because we have the time frame, so I only concentrate on the work what I have done. The performance metrics for my simulation result is throughput, media access delay, download response time, and average end-to-end delay. Before this, I will go into the simulations. In the OpNet modeler, we have the facility to simulate the result at a time more than 1 or more than 5, 10 scenario. So this is the very beneficial for me. I have created one network, and we are only change the in one environment the jammers, second environment with the WLAN Ethernet router, IP router, and second one is WLAN Ethernet bridge. And just compare the same parameter, because this is the main constant. The parameters involved in every scenario have the same, so we just compare the result. First scenario, this scenario contains with the jammer here, and here is the first scenario. This is the WLAN Ethernet, WLAN routers, and jammer is there. And there are 10 stations, name is Raku stations, the name is implicit that one. And second, similarly, the same, the reflection of the same, but you just see the router is different. Now, a router is a WLAN bridge router, WLAN with a bridge router. Now, the third scenario, that there is again WLAN router, IP router, but there is no jammer is there. Okay. And similarly, for the fourth scenario, now at the place of WLAN router, I will just put the WLAN Ethernet bridge router, and again there is no the jammer is there. Now we compute the solutions with some basic parameters involved in the intelligent jamming or the pulse jamming. We have some state machine cycle. There is no any. I was not put in the slides. And these are the jammer attributes. And attributes are model, jammer pulse advanced, altitude retained, jammer bandwidth frequency, that means channel frequency is 2.402 megahertz. Jammer bandwidth is 1 Mbps. jammer transmission power. This is important because this is a simulated. I was done some work regarding the power simulations, and that is the threshold point to check this one. 0.001 watts, pulse width, and 0.001, and silence width. Basically, the combination of pulse width and silence width is the total duration of the pulse of the jammers. Pulse width, how much time length the pulse or jammer is worked, and the silence is the interval of the one pulse to other pulse. Pulse directly related to your noise pulse. Okay. Throughputs. Just see how here the comparison of the throughput. Comparison of the throughput is when the router when there is no any jammer is there, then the constant is there. But when the jammer is not there, then throughput is for the WLAN bridge router is high, Ethernet bridge router is high, and here is this. So observation of this one, we have seen from figure 5, the throughput is highly effective. In the case of WLAN Ethernet router, here the value is 1460 bits, but in the case of WLAN Ethernet bridge, the throughput is high. In other two cases, when the jammer is not there, because there are four scenarios, one have the jammer, other have no jammer, like this. The throughput is same, so there is no any effect on the systems. So we conclude that the throughput is high, but this is not the verifications. First, we judge is there any jamming effect in our simulation environment or not. So through the media access delay, when we compare this one, this line is for IP router media access delay, and other ones is 0. So figure from 6, the media access delay is near about 10.15, and other one is near about 0. This shows that jammer with WLAN Ethernet router is highly effective. Now third observation is load. If the jammer is in your environment, is then should be a load increases in your environment. So just comparing the fourth, all the four scenario again. In the case of this one, pink line and this is green, and this shows that we have differed from figure 7. We will compare load in the case of WLAN Ethernet router and WLAN Ethernet bridge. In the presence of jammer, load is higher. But in the case of without jammer, the load is constant. So we conclude that jammer disturbs the communication from simulation result. The load with jammer is the amount is given 31811, and without jammer is this one. That means some load is produced by your jammer. Now data drop again. When there are two cases, when the jammer is present, their data drop is high. But when the jammer is not there, because we have created only up to 10 up to meters, and the nodes is only about 10. So that is the effect, and the data drop at the station is high. In last figure, the data drop station of a particular station. Basically, this is the data drop. I was choosing one particular stations, not particular environments. Particular environment shows by the load. Now the particular stations, is there in fact through the jammers or not? So we have observed that in the case of WLAN Ethernet router and WLAN Ethernet bridge with the jammer have drop data packet are very high. But in the case of without jammer, drop is not there. So finally, conclusion. In this paper, we have seen the performance of router under influence of jamming that can be launched in access point based 802.11b. Our network is conceived with the WLAN Ethernet router and WLAN Ethernet bridge. We had two observations. First, jammer is highly effective in the network because before the conclusion of the second point, first I proved that this one is highly effective in the networks. We have referred our results. We have observed that drop data packets, load, and media access delay, all results are showing that